Welcome. I think this is part 2, most probably lecture number 18, I think, because I don't keep count. Title you can see it. I'll come to last 2 types of questions for cylinders, and I'll give information. This cylinder questions, contact problems where two blocks or two objects are in contact. So many questions are possible. Right now, I will give idea for you how to solve. Because in structural engineering point of view, this won't carry much weightage. But this will carry heavy weightage if you are writing academic questions or competitive examinations. I will think later how to solve many more questions right now. See, question 1. Today's class question 1. I forgot the last time question. See, question I'll give words. Be careful, words I am giving. Sketch also given. See, 2 cylinders of diameters 300 given, 300 mm at the bottom and 220 mm upper side, or 2 cylinders are placed one above the other one and are placed inside what I can call inside 3 surfaces, or usually what they will tell is for the arrangement given in figure is the best one, or I will tell other way. Figure shows 2 cylinders where one of the cylinder is placed on other one. This is cylinder 1, this is cylinder 2. They are not telling. Now, cylinder 1 is of diameter 300 millimeter. Cylinder 2 is of diameter 220 millimeter. See, these two are different diameter. I am solving in the class. One extra question I will give you for solving. Usually in any examination, if they give such questions, what they will do is they will give same diameter to save the time. Okay, I have given different diameter. See, if I give different diameter and different weight, if you understand, same diameter, same weight is easier. Okay, now, next, cylinder 1 weight is say 10 kilonewton, and cylinder 2 weight is, they mean, see, someone will tell, they will find area you can't find because cylinder has got inside hollow portion. Anyway, material may be different. Weight will be 6 kilonewton. Don't try to compare with the diameter given in the question. 10 kN and 6 kN. Over. All surfaces are smooth given in the question. Find reactions at all contact surfaces is the question. Okay. Now, I will tell a solution. First, copy the sketch. Okay, then start solution. At that time, what you do is right here. This diameter equal to, they told how much? 300 millimeter. And they told this diameter equal to 220 millimeter. Okay. Now, this length they told, they have to give. See, if this is 300, this is 220, this diameter plus that diameter is 520 millimeter. If they give a length of more than 520 mm here, or if they give 520 mm length, what will happen? This will come down and will sit like this. See, if they give this length as 520, first cylinder is here, it will come here, second will come and rest here. That's all. Then there is no question of one cylinder placed over other one. Therefore, they have to give a length which is less than how much? This diameter and this diameter. That they have to take care. Yes, I have taken care. This is 400 millimeter. Next. And also, I should give this dimension more than the diameter of the higher cylinder. That much common sense required for the person who said the question. Then, this cylinder 1, I write here, weight equal to, how much I told? 10 kilonewton. This weight, they told 6 kilonewton, and all surfaces are smooth. It is not given in the question, all words given You transferred it. Okay, this is smooth. Okay, now one very, very important concept is there. Actually, that will come later in structural engineering with systematic way later, called action and reaction. But right now, too much I can't explain. I will explain how much is required for you. Okay, now draw one more sketch. See, I'll draw second sketch here because I want to remove this one now. See, I draw one more sketch. Little bigger. I'm not good in drawing circles. Somehow I'm managing. Okay. Somewhat okay. You should touch. Okay. Over. Now, this is center, cylinder 1. See, this is cylinder 1. This is cylinder 2. Now I'll do one thing. Usually red color I want to give for unknown. No, this time I will use black color for 1 and red color for 2. There's a reason for it. See, I'll draw this one once again. There's a very important reason. I'll tell you later what is the reason for this color. Till you understand. Actually, if you are serious, you should understand, or if you learn everything, you should not use this color solve. Right, this is your cylinder number 2. Now see, what I will do is, now I will use respective colors. Okay. This weight is, this side center I will call O1. This center I will call O2. O2. Red color stands for second cylinder, black color for first cylinder. This weight is acting down. How much? 10 kilonewton. This weight is acting down. See, this time red is not for unknown, it is color difference, 6 kilonewton. Now, see, this contact point I will call A. This contact point I will call B. This contact point I will call C. This mutual contact point I will call D. Some name required, D. Okay, remember, this is D. Or I'll do one thing. So wait, I'll mark it here. So here only I'll write. See, this is A, this is B, this is C, this is D. Okay. Now, very thoroughly explained. When you apply all these loads are there, this cylinder will try to move this side. So there is a normal reaction here, no friction, reaction RA. And this contact point is B. Since it is coming down here, there is a normal reaction here, RB. Now, this cylinder will press that surface. I told you, for smooth surface, reaction should always come towards it. This is RC. I think it is within the camera. I'll check it. Hope it is within the camera. Yes, okay, done. RC. Oh, see, not a mistake actually. Not a mistake. Anything for cylinder 2, I want red color. This is RC. This is RC. Just a minute. Sometimes should not go out of the camera. Okay, RC. Not over. There will be a what all I tell you should write. A mutual reaction here. See, if I join these two by a light line here, single line, center is here, okay. Then along this line, there will be a reaction here. See, one reaction for that one for this one. How to decide? See, correctly observe. This cylinder, upper cylinder, will push the lower cylinder this side. You will see correctly what I am telling. The upper cylinder will push it this way. So lower cylinder will get angry. It will push it back. Or there's a reaction here. This red color, see. Reaction on cylinder 2 from cylinder 1. from cylinder 1. Now, since this is pushing that side, that will push it back here. See, this will push it that way, that will push it this way. So, see, arrow mark here. Reaction, see black color, reaction on cylinder 1, or either you can call reaction or action, anything. See, or if this is reverse, R1, 2, from 2. Or you can tell, instead of reaction, simple language, you can tell how much force from to cylinder 2 on cylinder 1, force on cylinder 1 from 2, this way. Reaction, or you can tell one more thing, see, correct, clear, this way. See, this way. This will push it that way, that will push it this way. See? So, for this cylinder, reaction is black one. See, for this cylinder, this one. For this cylinder, this way. Understand correctly this concept. Okay. They are equal and opposite. So, of course, remember your R1 to R21 are equal. See how much, for equilibrium contact point, how much that will push it down, that much this will push it back. So, this is for this cylinder, this is the reaction on cylinder 1 from cylinder 2. You write here, this is reaction on cylinder 2 from cylinder 1. They are mutual reactions. See, or you can do one thing, you can tell this as action, this is reaction or common sense. This will push it this way, this will in balance push it this way. That much correctly understand. I will not explain once again now. Go through again. Now, see, now when you start solving here, this sketch I can remove. I got more space this side now. Now little more work is there. See, remember, two cylinders are of different weight and different diameter. Homework question or exercise I will give you when both are same. 400. Okay, I forgot right here. This is 400. This is 400. Now, see, O1, O2. Now, what you require? You require angle right here. Now, you require angles. See correctly. RA, crystal clear, horizontal. RB, vertical. RC, horizontal. No confusion. But 10 and 6 kilonewton are vertical. Again, no confusion. But this R21 and R12, you want angle. For that, do one thing. See this I write here now. R, reaction on 2, little bigger I write. One minute. I write here. Reaction on 2 from 1. Okay, now, light line join here. Light line. Let this angle be theta. If that is theta, once you get the angle theta, okay, now, that theta required. Theta required. How to find? See, mark the point O1 here. Mark the point O2 here, out of scale. This is O1, O2 line. Draw one horizontal line and vertical line. I will not repeat again and again now. Okay. This angle is theta. Now, this is what? Think a little. This is radius, this is radius. Therefore, this is sum of the radius of two cylinders equal to, this is this dia is how much? Remember, this dia is 300 mm. I forgot no other dia. How much I given? I forgot now completely how much I given. This dia, I think I told 220, I think, correct? Huh? I forgot, completely forgot how much I told. I think 220. See, now this is what happens when you come to the class without having a solved question. but this has got more weightage. I don't use any solved question. I solve in the class. I think most probably 220. If it is not 220, I cannot go now and stop the recording, see and again come back. So 220 millimeter. Okay. I forgot. So do one thing. By chance, if it is not 220, you change the question to 220. In the question you write, cylinder 1 is of dia 300, cylinder 2 is of dia 220. I think 220. Okay. Therefore, this will be equal to how much? See, this will be equal to, I write equal to 300 by 2 plus 220 by 2. Why means this question I can't answer. When this dia is 300, y radius is 300 by 2. When this dia is 220, y radius is 220 by 2. I cannot answer the question. Okay. Equal to how much now? 150, 250, 260 millimeter. 260 millimeter. Okay, now you know this length. See correctly that length. That length is from here to here. See correctly that length. I will do one thing now. O1, O2. I will call this point as O1, O2, O dash. See, light line O dash. Now, O1 to O dash is how much? 400 minus this radius minus that radius minus sum of radius of two cylinders equal. See here, this is radius. Y means no answer question, no answer. This also radius. See, radius of that cylinder, radius of this cylinder. Some 400 subtract this radius, subtract that radius. So from 400 subtract 2 radius together is 300 by 2 and ಇನ್ನೊಂದು 220 by 2 equal to 400 minus 150 minus 110, 140 millimeter. So 140. So this you got 140 millimeter. Over. Now you know this length. Use sin theta. Not sin theta. Sorry. You should use cos theta. Okay. Common sense. Don't waste time finding this one. Cos theta equal to 140 divided by 260. Therefore, your theta equal to 140 divided by 260 equal to shift cos inverse answer 57.421 degree. Okay, 421 degrees. Okay, accurate. 57.421. Correct? Huh? 1 ನಿಮಿಷ. Cos 57.421 is 0.53. Then into 260 is 140. Correct. Now everything is over. Now systematically I am solving the question very, very slowly because this is lot of concept based. I won't hurry. I won't tell in the class also high speed. Now this sketch I can remove. That's over. I'll remove this sketch now. Over. Now see. Now consider free body of, see correctly, of which cylinder? Doubt comes. You should have some understanding. See, any cylinder will not do. See now, make a note. I am dictating now. When you consider cylinder 1, unknown reactions are RA1, RB2 and R12. This one. 3 reactions are there. When you consider cylinder 2, unknown reactions are RC1 and R21. Only 2 reactions. See, we have got equilibrium, sigma Fx0, sigma Fy0. Sigma m is not used here. Momental will not come here. So, 2 equations available. Or if you use Lami's theorem, if applicable, there are also 2 unknown possible. So, first consider cylinder number 2. Cylinder 2. Make a note here. Y cylinder 2. Y cylinder 2, I will dictate once again, you write. If I consider cylinder 1, there are 3 reactions for it. RA, RB and R12. 3 reactions you can't solve. Only 2 conditions are there. But if you consider cylinder 2, only 2 reactions, RC and R21. So cylinder 2, if you consider that cylinder for which number of unknowns are lesser. Once you solve this cylinder, you will know the value of R12, and which R21 you will be knowing, but R21 equal to R12. Then when you come to cylinder 1, this is known. So that is the reason right here. See. Red color. Actually, red color is not required. Okay. Red color. Weight is down 6 kilonewton. Weight can be black, no problem. 6 kilonewton. One in the line here. One reaction here, RC. Then, see, along this line, where the angle made is how much I told? Oh, I rubbed it. See, I not entered here. Okay, enter here. I forgot. Now see, same problem. Again, I have to calculate now. See, it is 140 correct? 400 minus 150 minus 110 is 140. 140 nondu 150 plus 110 is 260. 140 divided by 260 equal to shift cos inverse answer 57.421 degrees. This is, I write here, 57.421 degrees. Okay, this is 57.421 degrees. Now, along this line, see, for this cylinder here, this is to be considered for cylinder. This is the force acting on cylinder 1 from cylinder 2. This is the reaction from cylinder 2 on cylinder 1. Or I told you, reaction should be always incoming. See, this reaction, red reaction. What is one? Reaction on cylinder 1. No, not 1. Reaction, this is your cylinder number 2. See, this is 2. Cylinder number 2 from cylinder number 1. Okay. Now, this you have to find. Okay. Sigma, now do one thing, as usual, let it be XX, let it be YY. Okay. Sigma Fx equal to 0, right side positive. Now I should not tell all these things. Plus R21, now I use black color only. Now no red color. Plus R21 into cos of 57.421 minus RC, see, that's all, equal to 0, equation number 1. Then sigma Fy0 upward positive. See, plus R21 sin 57.421 minus 6 equal to 0, equation number 2. Actually, from 2, you will get the value of R21. This R21 you will get. How much it is? 6 divided by sine of 57.421 is 7.120 plus 7.120 kilonewton. Substituting in one, which was equation number 1, you get the value of RC. Whatever you got, 7.120 into cos of 57.421 plus 3.834. So therefore, remember, I will make a note here. Your R21 came plus 7.120 kilonewton and RC came plus 3.834 kilonewton. Okay, now make a note. Okay, this is over now. Make a note. Here, make a note. When I consider cylinder 2, see this is a contact point O2, it's a O2 point. 1 force R21, 6 RC, all three are meeting here. Or if you observe clearly, three concurrent forces are meeting here. Therefore, you need not waste time, actually. Instead of sigma fx, sigma fy 0, even you can use Lami's theorem also. Right? Everything I am covering. If you use Lami's theorem, what to do? See, RC this way. See, RC this way. RC. R21 this way. R21 this way. The 6 down, you should write here. Why? These are acting towards the point. This is putting here. This is 6 kilonewton. This angle is 90 degrees. This angle is, see here, this is 90. If it is 57.421, this angle is 90, or you can do one thing. See here, if this is 57.421, this also same theta. So 180, I want this, see, I want this angle. See, this angle is 180 minus theta. That much common sense everybody will be having. 180 minus 57.421 is 122.579 degrees. 2.579 degrees. And this angle will be, see here, it is this angle. See here, this angle. 90 plus theta. 90 plus 57.421. 147.421 degrees. Or if you can do one thing, 147.421 plus 122.579 plus 90 will give 360 degrees. Now you can apply, this is not required, by Lami's theorem. 6 divided by sine 122.579 equal to RC divided by any R2, okay, first R21, okay, I use black color, R21 divided by sine 90 equal to RC divided by sine 147.421, you will get R21 and RC. Same answer has to come. Okay, check it. Why you check? Actually not required. 6 divided by sine 122.579 equal to 7.120 is R21 plus 7.120 Newton, kilonewton, innondu into sine 147.421 will give you 3.834 is other answer, plus 3.834 kilonewton, exactly same answer. Okay, done. Make this note. Okay, now see, make a note here. We know the value of RC, we know the value of R21. Now consider, this I'll remove. I thought I would do 2 questions today. No, today only one question, because important concepts are there. This concept solve, even though I am solving less number of questions, all this concept you require to solve such questions. So very important is at least any type of question, contact, see, bodies in contact when they give, if you know this principle, you can understand very easily. Now consider free body of cylinder 1. See, I'll write here. Okay, this side. Space problem, okay. Cylinder 1. See here, this is the point O1. There is a one reaction here. Which one? That is RA, which will come here. There is one reaction here, RB. Then one weight acting down here. How much? 10 kilonewton. And see, at inclined line here, O1, see, O1 to the, this point is D, I forgot right actually, this is D. Along this line, see, for that cylinder, this is the force acting. For this cylinder, that is the force acting. A force acting this way, black color force, are on cylinder 1 from cylinder 2. But of course, equal to R21, equal to 7.120 kilonewton. Okay, now for that one, this angle is 53 point, where is the angle? See, again forgetting the angle. What is this first of all? Such a, with an offline class, someone will tell that 140 divided by 260, shift tan inverse, not tan inverse, habit 140 by 260 equal to shift cos inverse answer. 57.421 degrees. 421 degrees. That's a habit actually. But usually tan inverse. It's a cos inverse. Okay, now see there. Sigma Fx equal to 0, right side positive. See, plus RA minus 7.120 into cos of 57.421, this component, this has no component, equal to 0, you get the value of RA. How much? 7.120 into cos of 57.421, 3.834 plus 3.834 kilonewton. Okay, then sigma Fy equal to 0, take upward positive, plus RB minus 10, this is not there, then see, minus 7.120 into sine of 57.421. These all I will not explain. Somebody may ask you, sir, why sine cos? Don't come to my class. See, I should be harsh on that one. RB will come 10 plus 7.120 into sine 57.421. 16 kilonewton plus 16 kilonewton. Right. Now, therefore, everything is over now. I will, now one more thing. Someone will ask, sir, what about Lami's theorem? See, 1, 2, 3, 4. So, 4 forces, directly Lami's theorem you can't apply. But in this case, if you want, for you, it is an exercise for you, don't it? It is for you. If you want, for you, you can apply Lami's theorem, because I'll tell you, these are collinear. What you do? Put RA this way and R21 this way, R21 equal to how much? R12 equal to R21. R12 equal to R21 equal to 7.120 kilonewton here, and this is incoming, it should be incoming. Put this one as RB minus 10, and then this is 90, this angle will be how much? This angle will be, see this angle, 180 minus theta. 180 minus theta. 180 minus 57.421. 122.579. 122.579 degrees. This angle is 90 plus theta. 90 plus 57.421 is 147.421 degrees. Right? What? See, RA divided by sine 147.421 equal to RB minus 10 divided by sine 122.579 equal to 7.120 divided by sine 90, solve, you will get same answer. RA will come, your RA will come, and one more, which one? RB will come. I will calculate. RA plus 3.834 kilonewton, RB plus 16 kilonewton. Okay. Question is completely solved. Now, one very important concept. Okay. I will put the final answer if you want. I do one thing now. I will write the final answer to understand. See. Therefore, you can tell here the reactions are how. See. There is one bigger cylinder here. One smaller cylinder here. Okay. This weight is 10 kilonewton. This weight is 6 kilonewton. There is a reaction here, normal reaction. This contact point is A, this contact point is B, this is C, this is the D point I told. There is a horizontal reaction RA inwards of 3.834 kilonewton. There is a vertical reaction here RB of 16 kilonewton. There is a horizontal reaction here C, RC of RC 3.834 kilonewton is not required. 3.834 kilonewton, and here there is a reaction here and a reaction here. This is cylinder 1, this is cylinder 2. Reaction on cylinder 2 from cylinder 1. Reaction on cylinder 1 from cylinder 2. And both these are equal to 7.120 kilonewton is the answer. Now, I am not seeing the answer. I am taking a risk. I will tell you something. If it does not tally, from next time onwards, or today will be the last class I am going to take. 2 cylinders are resting. This weight has to transfer here because why? This is a smooth surface. Weight of cylinder 2 has to be transferred to cylinder 1. Finally, when you come to ground contact here, cylinder 1 and cylinder 2, both weight will be transferred. That is 6, this is 10. So this reaction, my guarantee should be 16 kilonewton. Let me see. Yes. And these two internal reactions will cancel each other. See, internal forces will cancel each other. Therefore, if you see the overall equilibrium, this support and this support will get pushed this way. For equilibrium, no horizontal force is there. They should be equal, 3.834, 3.834. Yes, what I committed, it came correctly. So class will be continued. Okay, now I'll do one thing now. I thought I'll do 2 questions. No, one I'll do tomorrow. One exercise I will give you. Exercise. You solve this question. I will give answer in tomorrow's class. Next class I will tell you the answer for you. Here, one cylinder, easy question. One cylinder here, one more cylinder here. See, both cylinders, question. See, this is extra question for you. Extra question. See, all are smooth surface. See, this length I will tell you. See, in the question given, both cylinders are identical. Each are identical. Each of them diameter is 100 millimeter and weight equal to 4 kilonewton. Therefore, one thing guaranteed now, this reaction has to come 8 kilonewton. Okay, over this distance I will give you. If the diameter is 100, 100 plus 100, 200, I have to give less than 200. If I give more than 200, it will fall down. 170 millimeter. This question you solve. Next class I will tell you answer for previous question, direct answer. See, now when you want this angle theta, it's easy. Last time, see, half of this diameter, half of that diameter, this one, half of radius is same for both. This question you solve, and next class I will give the answer. By chance, I have to make a note now. Okay, I will make a note. Okay, there's a contact is there. I don't think contact is not there. I'll wind up the class. I think I need one more class to complete, because I will tell you what is next. Last question. Last question is 2 cylinders here and one more cylinder above that one. It's like you store laddus. See how people store in hotels all. Have you seen laddu storage? This way, laddu storage. Okay, that is the last question. Then I will take one extra class for giving importance to further, for support reaction, everything. I will explain one more class. So next class will be the last for equilibrium questions. Thank you.